I hope you are doing good. So today we'll study about try data structure. Let us see how it is useful in the real life, right? So let me search. So see here, when I write Shah, right, you get Shah Rukh Khan, Shahid Kapoor, and Shaheen. So how does Google know that? And it searches for these three examples. So let us study these little carefully and understand the trie data structure. When you search for three elements, S, H, A, H, we got results about for these Shaheen, Shah Rukh, and Shahid, right? So we see that SHAH is common, and then it is trying to search what is there after this, right? So let us trace back as to what data structure could be used here. You can see that somehow all these are connected, and SHA, and then after that there is an E, there is an R, and there is an I here. So we know that this H is connected to E, R, and I. So we know that there is some node and which is connected to E, R, and I, right? And again, these are again connected to the respective words, right? So this is how Shaheen is formed, and then R, U, K, and H. So here it boils down to ID. So we know that once it comes to H, it actually knows there are three words which ends with H, right? So this is how we can construct a trie. We know that every node is connected to some node, and then if the letter is different, we have a new node. So trie basically has a node, some kind of node, and then it actually links to one more node, right? And usually the elements in the nodes are lower case string elements. So we can assume this kind of relationship in a dictionary, right? So this will be like uh, there is a root node, and then you search that, okay, do we have h there? No, then we insert and then we proceed. So this is about uh, what the trie does. So let us understand what happens before this h, right? You have h is connected to A is again connected to H, and then it is connected to S, right? So how do we know that the whole word is complete, right? So we need some kind of parameter which says that it is complete. So that's why for every node, right, we have one more parameter is complete, right? So we know that in trie there are two. One is a dictionary, second one is complete. So here is complete will be false, 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 will be false. And here there is an node which is of empty, which tells us that this is true and this is a complete word, right? The same case here, right? The same case here. So we know that all these three words share a common prefix. So that's why tries are used for a prefix search, right? prefix search. So in try, basically we have two components. One is the dictionary which we use, and the one uh, is a boolean variable is complete, which tells us whether the word is complete or not. We have understood why try is used. Let us try to learn more about it and see that are what all methods are used in order for us to use a try, right? So we know that there is a node which connects. So we have a node which consists of a dictionary and a boolean variable which is complete, right? So we know this one. So in order for us to construct a try, we need to use this node, that is for sure. So in order for us to construct a try, we need to use this node, that is for sure. So let us understand what all things would be there in a try, right? So in this, uh, we would obviously have the root, which actually is a node, and for we need to insert the letters one by one, right? So we need to have some sort of insertion technique, and we need to have some sort of search, right? If you want to search, so as I showed in the example, if you type in shah, it shows three words: Shahrukh, Shahid, and Shaheen, right? So it actually searches till here and looks for other words, right? So we need to have a search function in that, and we also need to know the prefix or prefixes of the words, right? So what are the words which starts with sha, right? We need to know this as well. So these four constitutes a trie class, and this trie class obviously uses nodes which connects these letters. Start implementing the trie data structure we have seen. So we know that there are two parts in this. One is the node, right? So let's define the node, and we know that takes in node has two things in that. One is the dictionary. So I'm going to define the dictionary which is used to connect the words, and then a boolean flag, which tells us whether the word is complete. So we know that there is one more, so actually the try function, try class, which we are implementing. So it it has one parameter which is root. So root is actually nothing but the node, right? So each of the nodes gets connected to. We discussed that in try we need to have a insert function method, uh, which actually inserts the word. So let us go to the root always. From the root, we are going to check whether uh, the character is there. So I'm looping through each of the characters in the word, and I'm checking whether that particular character is there in the word, right? Let me change this. Yeah, for character, uh, not in node dot children, right? So each of the nodes have two attributes. One is children, and we are checking in the dictionary whether that character is there or not. So if it is not there, we need to create that. So for that children, and we keep it as a key and we equate it to one more node, right? And so if it is not there, then we are creating it. If it is there, right? So we need to move ahead, right? Node equal to node dot children character. So this actually moves to the next node. And once the loop is ended, we have to make sure that we need to put this flag is complete equal to true, right? So at the end we need to, and then we also talked about searching a particular word, right? So search is also pretty simple code. It resembles. So we need to know the self for. We need to know the root. So we have to go from the root and for a character in word, right, which we are searching, and if that character not in node dot children, right, if we don't find that character in node dot children, we return false because we have not seen that particular character, and if we see it, then we actually move forward with that particular character, and at the end of that word we actually return if the word is complete or not. So at the end we return this parameter, right? And we also talked about one more, which is prefix. So if we have a prefix of something, let's see, check whether we have that prefix or not. So in this method prefix, we can have with starts with is actually a string. So we have to go from root, and for every character in the word we need to check if the character not in node dot children, then we return false, right? We don't find it, otherwise we move forward. And at the end, we after we have seen, we return true. So basically this is how we implement uh, the trie data structure. We have for the load we have two things: children, which is a dictionary, and is complete, which will tell us whether the word is complete or not. In the try node, we have a root which starts with an empty node, and again we have insertion. So if you want to insert, right, suppose SHAH, right, it goes to the root, and for every word, so S, it checks if S is there. No, it is not there. Then it creates a dictionary which has an empty node in it, which creates with S, and then it goes forward, right? It moves to that empty node, and then it checks it's not there. Then it creates one more node. So as and when the full word is complete, it marks that particular node as true. Same thing happens with the search. If we don't find that particular character in those children's, we straight away return false. Or and once we end with the whole word, and we see that whether is complete is set to true or false, right? And if you want to search with if you want to know how many prefix or what is a prefix, so how many words start with sh, right? You go here and search for every uh, characters. If we don't get that, then just return false, and we traverse like this, and after we find sh is there, then we return true. So this is pretty much how the trie data structure looks like. let us see the time complexity. So in this, the time complexity would be O of length of word, right? We need to search through all the sentences. So length of word into the number of words in it. So worst case, we have to go through all the words and then say it. So insertion will be time complexity will be length of word into n.